Okay, we're stuck at home in isolation at the moment, so I just thought we'd make a video to try and improve the general knowledge in my industry. I thought I'd make a video today on CTCSS. And my apologies, this is my first whiteboard video. I hope not to make too many faux pas, but anyway, CTCSS. What is it? How does it work? We'll start with a name to start off with. Continuous is what the first letter stands for. So whatever it is continuous. T stands for tone. So it's a tone-based system. C is coded. You could quite easily change the C from coded to control. Either word works, doesn't change the meaning at all. This one here is the most important one in the description, squelch. In actual fact, I'm going to change this a little bit too. I'm going to add the word receiver in here. It's very important. The squelch is part of the receiver. The last word is system. So we have a continuous, tone, coded, receiver squelch system. However this thing works, it uses a tone, which is there all the time. Coded, you could exchange the word coded for control, but what we're going to control is the receiver squelch. And that's the most important thing to understand here. We are going to control the receiver squelch. That bit of understanding is vital. Without that small piece of understanding, the rest of the discussion is, immaterial. So we have a continuous tone control of the receiver squelch, and it's a system. Okay, the second step with CTCSS is to have a little bit of an understanding of how the receiver works. An antenna. You'll have some sort of preamp, bandpass filter, mixer. And this is going to be your oscillator. And this oscillator is of course going to be controlled, because popping out from this mixer is going to be your IF. In fact, you might have more than one IF. You might have, it's most common for there to be two IFs. I'll only draw one for the purpose of this, but let's assume that we can shift this down to an IF frequency. We will have more gain in here, and then we will have some sort of discriminator or some sort of detector. We will then have a control here, and I'll just draw that as a switch. Then there will be an audio amplifier followed by a speaker. Here's our simple receiver. In this detector circuit here, we are going to have a CTCSS detector circuit. We will also probably have something coming out of here which will give it might be an LED light. I'll just draw it as a diode, or it might be an S meter. So you'll have some sort of signal indication. Okay, so coming into the front end here, we'll have our signal, our RF. It's going to be downshifted through various stages to get to the IF frequency. It will be amplified, and the detector will be able to detect what's on that signal and discriminate it, and we will have some sort of CTCSS detection circuit. Now that CTCSS detection circuit will be able to provide an output that will drive this switch. So we've got two situations here. If the CTCSS circuit is looking for a particular tone, and we program that into the radio, let's throw a tone in here, 107.5, and that's 107.5 Hertz. So we're telling the radio that we need to look for that CTCSS tone. When it's detected on the incoming signal, regardless of how strong the signal is or whether there's a signal present here or not, these are the indications that tell you whether or not you've got a signal there or whether or not you've got adequate signal strength. But the audio doesn't turn on until the correct tone is detected. Once that tone is detected, then the audio turns on, this switch closes, and you get audio out of the speaker. That's generically how CTCSS works. So it's a tone control of the receiver. Now we need to actually talk about the situation where the incoming radio signal here is just an incoming radio signal without a CTCSS tone. When that occurs, you can't stop the RF from coming down the aerial and going through the first part of the circuit. But if there's no CTCSS tone riding on this signal, the detector isn't able to pass anything to the CTCSS control unit. Therefore, this remains open circuit. No audio comes out the speaker, and regardless of whether or not you've got a signal here or what strength it is. And that's the most important thing. In actual fact, no, it's not. If the CTCSS tone that's riding on the signal is not matched with that one, this doesn't turn on. So you can actually have incoming RF signals with no tones on them, and that won't turn on. We can have incoming RF signals with incorrect tones on them, and that won't turn on. Only when there's a correct transmit tone coming in here on the transmit signal coming down into the receiver aerial will that turn on correctly. So for CTCSS to work correctly, and this is the most important point, you have to program the correct tone onto the transmitter and on the receiver. So when you're programming a radio, for this thing to work properly, CTCSS must be programmed on both the transmitter and the receiver. Now the most common mistake, the most common misconception, the most common error that I find with CTCSS in use is that it's very common to put to program a CTCSS tone on a transmit signal. We'll just draw a transmitter over here like that. It's going to send a signal into our receiver, and they put the tone on here. They put 107.5 Hertz transmit tone on the transmit signal, so that CTCSS tone is programmed here. The most common thing I'm finding is that there's no control here. There's no tone. Therefore, this CTCSS control is not working. Therefore, because there is no tone here, there's no tone control whatsoever because it's not programmed into the receiver. If you do not have a tone programmed in here, or in some cases it's programmed as CSQ or squelch, this remains closed the entire time. That means that every signal that arrives here at the aerial will result in an output at that end. And that's a problem. That's a problem because the CTCSS control within the radio here doesn't block unwanted signals, and those unwanted signals might be a form of interference, and it doesn't block other users of the same frequency. So you could have an entirely different company over here with their transmitters with a different tone. Let's draw another one, 94.8 Hertz. So this other company that's operating over here using the same frequency is generating a signal which will also go into this receiver. It'll go through this system, but because this has been incorrectly programmed as CSQ, there is no receiver control here. The audio will come out here. This receiver then becomes open to every signal, including interfering signals, and becomes open to co-channel users on the same frequency. So by negating to put a CTCSS tone into the receiver side of your programming, you're completely negating the entire CTCSS tone control capability. You might as well not have it at all. And the user of this receiver will suffer from co-channel interference from other users on the same frequency, despite the fact that they're using other CTCSS tones. And the user of this radio will also suffer from interference. Because one of the primary users, or one of the primary reasons why you put CTCSS on top of signals, is that 9 times out of 10, interference, which is generated by man-made pieces of equipment, don't have CTCSS tone controls riding on them. This system, if it's correctly programmed, will block or negate that interference because it won't be allowed to pass through and provide a signal at this end, coming out the speaker. And this problem, unfortunately, is very common. It's very common to find CTCSS programmed on transmitters, and yet the receiver squelch is left open. Right, what we're going to do now is we're going to continue our discussion with CTCSS. And we're going to talk about a situation where we have multiple users on the same frequency, and the kind of situation that you can get into. Now, I'm going to use an active example from my district. Those that are in the know know that they use a frequency of 150.76250. That frequency is ENX57, and we actually have licenses given to multiple companies on this frequency. And this example is actually quite a good example because it illustrates the kind of mess that you can get into with incorrectly programming CTCSS tones. I won't use company names. I'll just go A, B, C. Company A applied for a frequency. They were the first people to apply for this frequency, and their license stipulated that they are to use 88.5 as a CTCSS tone. So Company A set themselves up in business. And they're operating over here. Unfortunately for Company A, the transmitter was set at 88.5 and the receiver was left open. Now initially all worked well. All worked well because all the radios were set up the same way. And again, this receiver was left open. So when this set transmitted to this one, not a problem. It had a tone on it, but the receiver was open, so we had satisfactory transmit in that direction and the system worked, and vice versa. When this person transmitted back the other way because this receiver was open, everything worked fine. However, we had a small problem because Company B came along. Company B was given a license on the same frequency, and they were given a CTCSS tone of 127.3. We'll draw Company B over here in this corner. Now, Company B on the transmit had 127.3, and on the receiver it also had 127.3. So these radios were correctly programmed. Again, the transmitter is 127.3 and the receiver is 127.3. So Company B were able to transmit and receive between the mobiles in their fleet quite satisfactorily. Unfortunately, signals from Company B were also received over here at Company A, and that's because these receivers were open. They were probably programmed CSQ, but either way they were open. So Company A began to receive co-channel interference from Company B. Company A tried to transmit back in that direction to tell them, "Oi, get off our channel." Unfortunately, their transmit CTCSS tone is 88.5, and over here this receive CTCS control was looking for a tone of 127.3. So in that direction nothing worked. That's a minor problem. Now this particular issue got worse because we had Company C come along. Company C also got a valid license to use the same frequency. Company C's CTCSS tone was 118.8. These guys, I'll draw them down here, quite happily able to talk among themselves. They were correctly programmed with TX of 118.8 and RX of 118.8, and I'll draw it here again just to illustrate that there was actually a fleet involved. Okay, so Company C are able to talk among themselves quite happily. Company C, when they transmitted in that direction, didn't provide any interference whatsoever to Company B, because the CTCSS tone that they were transmitting over in this direction had no effect whatsoever on these receivers. So not a problem. Company B and Company C were able to use the same frequency in exactly the same physical space. However, company C were also transmitting in that direction towards the first company involved here. They were transmitting a tone of 118.8, but this receiver's open, it's programmed CSQ. So company A ended up in an interesting situation. By virtue of the way their original programming was done, company A began to suffer from interference from multiple users, and these users were correctly licensed, but they began to suffer from multiple users on the same frequency. The most serious problem here is this one. A failure to correctly program the receiver squelch with the correct CTCSS tone. Leaving this end of the receiver open provides a perception problem. The perception is that the band is full, that the channel is full, and that perception occurs because of this co-channel interference. It's not necessary. These two groups, company B and company C, are able to operate quite happily in the same physical space, and so would company A as well if this receive CTCSS tone had been correctly programmed. And this particular problem is a problem that's fairly endemic, and it occurs simply because of this. If that's the one message that I want to get across with respect to this video, is that when you're programming radios with CTCSS tones, you must put the CTCSS tone on the transmit as well as on the receive, otherwise it won't work properly. This system, the CTCSS system, will be completely negated. You must put the CTCSS on the transmit as well as the receive.